Thank you for joining today's webinar. My name is Brian Stone. I work at Helwig Carbon, and I will host this webinar on VFD induced currents, detection and mitigation methods. I'd just like you to know that we have received a series of questions about this topic, and we'll be getting to those questions at the end of the webinar. Okay, if you have additional questions after the webinar or have some other items you'd like to share with us, please contact Liz Cottrell at the address you see on the screen. There's Liz and me. Again, I'm the applications engineer here at Helwig. Liz is the marketing coordinator and will handle all of your questions or requests for additional training, things of this nature. Let's get started. Leading causes of electric motor failures. You can see 51% of the failures are from bearings in your electric motors. Half the failures of the motors are due to electrical wear of one form or another. This is a bad thing. This is what we're here to talk about and address today. And this is not our stat. This comes from IEEE. How do you know you've got a bearing failure? What makes you recognize your motor as having common signs of premature bearing failure or bearing failure at all? The first thing you want to do is look for vibration in the motor. The roller elements of the motor are running over a rough surface due to deterioration, and the motor shaft begins to vibrate, and it's felt throughout the motor. The motor will be getting hot. You can literally hear the vibrations when you get near the motor. And one of the first things you should look for is if you have burnt grease, not grease that's dark in color, but actually burnt black grease. The net result of bearing failures: downtime, production, and costly repairs. What does VFD motor bearing failure look like? Typically, you're going to see a fluted pattern like you're seeing on the left. That fluted pattern will be on the inside and outside of the raceway. The ball bearings themselves will become frosted. If you look at these elements very, very closely, you'll see that frosting and even the pitting on the ball bearings and the washboard that you see on the raceway, these are if you look at them very, very carefully, they are actually microscopic pits in the bearing and roller elements, and that's where the noise and all the other bad things come from. The other thing we're going to look for right away is burnt grease. You see that on the right? It's a leading indicator that the bearing has failed electrically. Okay, we're talking electrical failure, electromechanical, two different failure modes. Black grease, the fluting you see in the frosted bearings are definite indications of electrical wear. What causes this electrical wear? Motors driven from VFDs or other PWM sources generate an imbalance in the motor shaft. That shaft, an imbalance in the motor, and that ultimately causes a buildup of static on the motor shaft. That static builds and builds until it finally finds a path to ground, typically through the drive end bearing, arcs through the bearing to ground. The shaft builds voltage, arcs through the bearing to ground. Each time this happens, and it happens quite frequently, it damages the raceway, the ball bearing itself, and the grease. The more this occurs, the worse the problem becomes, and it begins to snowball on itself. The other thing that's going to cause the problem in the motor is circulating currents. Circulating currents are typically only things you'll see above 100 horsepower, typically, before they begin to damage your motor and bearing. If you're not seeing electrical discharge through common mode, through PWM sources, we also should address circulating currents within the motor. That's a separate issue, and we can address that. What are the root causes of the bearing current that we see? Remember, we see a shaft voltage build and build and build until it gets until there's so much push behind the voltage that it'll arc through the bearing to ground. What's happening is there's an imbalance between the three phases of power going from the motor drive to the motor. This imbalance comes from a digital version of the three phases. The digital version is each phase is out of phase with each other, but also out of balance with each other. This imbalance between the phases it causes a cumulative effect called common mode. The common mode builds on the shaft, builds, discharges through the bearing. it causes premature bearing failure. If you want to get into more detail on root causes for bearing current, give us a call and we'll give you a more detailed analysis tests. We'll do a quick Teams meeting with you, things like that. Root causes, again, the accumulated electric charges build on the bearing and it finds a path of least resistance to ground that is typically through the drive and bearing, though it could be through your gearbox or any connected equipment. Voltage greater than, if we see a voltage greater than 2 volts, it is damaging your bearing. There's no question about that. We have the motor lab here at Helwig. We've done extensive testing, really around 1.6, 1.7 volts. The discharge is enough to cause damage. We're conservative here, so we say if you're up to 2 volts, you are seeing bearing damage. Remember, you cannot measure this with your voltometer. We'll get into that a little more later. Why do we measure voltage instead of current? Current's actually doing the damage to the motor shaft, not voltage. But we measure voltage. How come? First of all, voltage is a lot easier for technicians in the field to measure. This simple point and shoot device, we can easily measure current and or voltage, and we can measure it in a way that is very accurate and it's very difficult to mislead. When you measure current, it very much depends on the setup of the test itself for the accuracy of the reading. As you can see, when you measure voltage, current follows voltage. So if we can detect a voltage spike, the current spike follows it. As you can see in the slides below, the two are very, very closely related. If you see one, you're seeing the other. So we measure voltage because of the ease at which it can be measured accurately. Now, we've determined that you have a problem. Your motor is driven from a pulse width modulated source, a variable frequency drive. We see that it's damaging your bearings. We talked about some of the cause and effect of that. Burnt grease, fluted raceways, things of this nature. And there are a bunch of different mitigation sources out there. Let's talk about just a few of them. Insulated bearings. You can insulate the bearing from the motor case and prevent arcs through the bearing, and it works. However, it's a very expensive solution, and you have done nothing to prevent the arc from common mode voltage occurring elsewhere. Remember, it's going to look for the path of least resistance. If it isn't through your bearing, it's very likely through the gearbox that's connected to it when the gears lock up, or other downstream connected equipment. Just because you've insulated the bearings and saved the motor bearings does not mean you have reduced the problem of arcing internal to the motor or from connected equipment downstream. Inductive chokes, they work. They're partially effective. They're primarily for the windings in the motor, and more so than they are for common mode voltage. But we would encourage you to use inductive chokes. They are good things, but them by themselves will not solve your problem, and we can show that. Conductive grease, we will never recommend conductive grease. We've done extensive testing on it. It actually encourages bearing discharges. If someone is asking you to use conductive grease in your bearings, please be cautious. Do your homework. Give Helwig a call. We'll be glad to show you our tests that would very much discourage you from using conductive grease in your bearings. It sounds like a good idea. It is not. A very common mitigation source out there is the carbon fiber ring. This is an effective device, especially initially, and it does take the voltage and reduce it. It certainly does, but it does not bring it down in many times below the acceptable 2-volt level after a short period of time. Initially, I think you'll find it does, and it works well. But after just several months, I think you'll find that the contact force reduces. And if the contact force reduces, the voltage on the shaft increases, and the likelihood of a bearing discharge also increases. What does Helwig Carbon do? We do things a little bit different here. We put a silver graphite brush and with a spring behind it and maintain force on the shaft. That means, remember, the force is everything. That means we have the day we put it on, we'll work as good as we will 5 or 7 years down the road from now when it's still maintaining contact. It's very important to know that the contact is everything. Silver graphite, a very, very low friction, very, very low resistance product. and it works very well and very good at high frequency. It works very well at high frequency. That's why we use silver graphite, and we don't paint silver on the shaft. We simply put the silver in our kit. Gotta have silver to be effective. We embed it into our kit. We do not paint it on the shaft. Therefore, we have no maintenance. Once we're installed, you never have to take us off, paint colloidal silver on the shaft, ever. When we're in, we're done. Okay. It's very important to note that the difference between our product and some of the other products that are out there. Please, we encourage our customers to become very educated. Do some learning on your own. Give us a call. Give our competitors a call. Do some side-by-side comparison. We very much look forward to that. Now, how do you detect shaft voltage? You can call in a vibration specialist. Generally, what they'll do is they will monitor your motor. They will watch for anomalies in the motor that are mechanical in nature, and they will go, yep, your bearings are fluted. Predictive and preventative maintenance guys can do the same type of thing. They'll come out, they'll monitor everything, they'll let you know there's a problem along with your motor repair shop. After your motor has failed, you send it in. Encourage your motor repair shop to open up your motor, look at the grease, cut the bearings, look at the bearings. Let's find out what the source of your failure was. Let's not just put a new bearing back on there or have somebody talk you into isolated or insulated bearings. Let's not do that. It's a lot of expense. It's unnecessary, and it's probably not the right thing to do. Let's just make sure it's right. So what do we got to do? We have to get on that motor shaft with an instrument that can detect voltage discharge. That's what this little device is here. You simply place it against the motor shaft, pull and hold a test trigger on here, and within moments you will see the risk to your motor, if there's one at all, and what that risk is. Okay, and then we record and store all that information. We do all that stuff. We can learn more about the probe. If you need more information on the probe, how it works, what it does, what it doesn't do, its limitations, things like this, give us a call. We'll be glad to give Liz a call, and we'll be glad to set up a demonstration for you through Teams or in person. One thing I need to clarify, this is something we bump into regularly. Folks in motor shops are out in the floor. They take their very good Fluke or other very, very well-designed multimeter. They go against the shaft to ground, and it measures 0 ohms, and they go, we must be good. They put it on the voltage reading. They measure between the shaft and ground, no voltage, and they go, there, our motor is protected. It is exactly not true. You may never use a multimeter. No matter how good your multimeter is, you may never use it to check for bearing discharges. The way the multimeter processes its operating frequency, things of this nature, the RMS output on it, it all deters from an accurate reading. Please do not ever use a multimeter to check for bearing discharges. Predictive and preventative maintenance. It's an important part of what we do. We want to make sure that we can not only predict when your motor is going to fail, if it has a problem, when it's going to fail, but also the maintenance part. We want to eliminate the problem, not just detect it. It's something we do a little different. Put the probe on the shaft. We can tell you if you're seeing voltage discharges. If you are seeing voltage discharges through your bearing, this will detect and record that data for you. We can measure the risk to the motor. How bad is the discharge, and how likely is it to damage the bearing? And that just takes seconds by pressing the tip of the probe against your motor shaft. What does the tool feature? It features a number of display test results. Very simple, very easy to read. It'll tell you if your bearing's passing or failing. It'll tell you if you have a ground fault. It checks for grounds. It'll tell you if you're passing, but just barely, with a yellow indicator. So it kind of gives you a good reading just this quick on this display with the answer recorded and maintained for future reference. When you use a kit, if you want additional, more detailed information, because you're going from a technician, let's say, to an engineering level, you're really trying to solve a difficult problem, The unit itself has a BNC output on it, and the kit comes with an oscilloscope. Simply hook the probe to the scope. It's preset to work with the probe. Plug them in, turn it on, and you will see what's going on in your motor. If you capture that data or otherwise maintain that data, you can easily grab it, send it into Helwig, and we'll be glad to analyze that data or work with you specifically to understand the captured data and help determine exactly what's going on. So as I was mentioning earlier, you get the scope and the probe. The kit comes complete. We don't make you buy other stuff after you buy the kit. You buy a kit, you have everything you need to walk up to any motor and do testing. As long as you can get to the motor shaft, you can test and record. So it's a pretty complete kit. And if you have any questions on the kit, give us a call. If you're going to use the oscilloscope, if you're going to go beyond a straightforward test result, risk analysis that this gives you, if you want to go more in depth, you hook this to the oscilloscope. And here are some typical readings you might see on an unprotected motor on the left. Each one of those spikes is a discharge. Each one of those is an arc and is ruining the bearing. On the right, you see if you install it's a brand new carbon fiber ring, you can see that it does help make things better. And that signal will only deteriorate as time goes by as the force of the fibers decreases. And with our kit installed, because we maintain force with a silver graphite high frequency brush, we expect to see a result that is a dead flat line for the duration, the life of the brush, which is going to be, for in most cases, 5, 7 or years or beyond, typically. Okay, we make a variety of kits for a variety of applications, little guys, medium size, and big guys, depending on your application. We maintain shaft voltage for 30-inch diameter shafts on cruise ships and submarines, and we all the way down to small motors for your washing machine. Okay, give us a call. We can always specify the correct kit for your application. Here you see examples of bearing protection kits mounted on a variety of motors. Remember, we not only come at the shaft axially with pre-made brackets for your motor, so you can just simply loosen bolts, put our kit on, tighten the bolts back down. No pulling apart, no discoupling or decoupling your motor from your downstream equipment, installing, drilling, tapping, reassembling, realignment. We don't have to do any of that with our stuff. If you can't get at the motor shaft, we also make a variety of axially mounted kits, so we can come at the shaft axially instead of radially. That is to say, we have a variety of kits. Our website includes our basic kits. If you see something on there that has your interest, or you go, wait a minute, I got something a little different, give us a call. We're confident we have a brush for you or a brush application. Another big advantage that Helwig offers, if you have motor shafts that are from 1.5 inch or, let's say 1.5 to 4.5 inches, which covers almost everything, you only need one kit. You don't have to have a different kit for each slight increase in shaft diameter. One kit does the whole thing. With our multi-fit bracket assembly, same bracket, same kit, same everything. Stock one kit, maybe two if you really have a wide variety of motors, and you have all of your motors protected. You don't have to purchase and stock a variety of mitigation solutions for every different shaft diameter. Don't have to drill and tap, don't have to put on some colloidal silver, don't have to use conductive epoxy, none of these things. Loosen the motor bolt, slide our kit on, tighten that same motor bolt right back down, walk away. Okay, it's pretty slick installation. What is this thing doing? How does it work and what's going on? Again, we have a proprietary silver graphite material in our brush. This is completely maintained by Helwig. We literally make it from scratch out in Pennsylvania. We maintain this process 100%. It's a very specific grade that we do not market or sell outside of Helwig carbon. In order to get this performance with this life and this wear rate, you must purchase our kit. We keep a spring behind the brush because we want to maintain a force on the shaft. Force, PSI at the face, at the tip, is key to performance. That's why other guys' stuff wears and it no longer, like a toothbrush, it just no longer has the force when it's 6 months old as when it was new. That reduction in contact force is a reduction in performance. It's one of the very strong advantages we have. Plus the high frequency capabilities of silver graphite used on Ethernet, CAN bus, other medical applications with very high switching frequencies. It's handled every day by our kits. So don't be misled by carbon block theory or anything like this. We don't use carbon blocks. We make sure through magic of our material scientists that our devices last a really long time. I know how important that is to you. This is a set and forget application. Once you put it in, you should not have to do any maintenance to it at all. Never take it off. Never, ever paint silver colloidal silver on the shaft. Never have to clean the brush path. It maintains its own clean path. It's just what it is. It puts a conductive layer down. That conductive layer, some people might say, well, you don't want a layer on there because that adds resistance. Not if it's a silver graphite layer. It actually is a conductive film we put down, which adds a lubricant, which even increases the brush of the life more. That's all part of our K007 grade and part of the magic that's in there. As you can see here, we're going to mount our kit right up on the shaft. It's going to physically contact the shaft. That's going to take the charges that you see in the yellow arrows that build on the shaft, the common mode voltage, and it's going to redirect that voltage through our brush to ground. We do not allow discharges through the bearing because voltage, like anything else, is going to find a path of least resistance. And we're talking micro ohms of our resistance from our brush to ground. Well, of course, the voltage and associated current would much rather travel through our solution than through any other potential short or path to ground. We absorb literally all of the damaging current and voltage through the motor. We have a variety of mounting options. You can drill and tap if you want. We have a dual lock that's an industrial mechanism used or developed by 3M specifically for motors and motor shops, other things like that. It's an industrial thing. When you stick it, it really sticks. And that way you don't have to drill and tap. You can go in the field, you can snap one of these things into place just like that. Your motor's protected. We also have a series of multi-fit brackets or custom brackets made specifically for motors. Here you see one on a motor. As you can see, we used existing motor bolts. We loosen the motor bolts. This bracket comes with the kit all mounted, done and done. Loosen the bolts, put the bracket on, tighten the bolts, and walk away. It's really kind of a clever design, and again, it prevents you, especially for OEMs or mod shops. You don't have to drill and tap. You don't have to, no conductive epoxy, no special preparation of silver on the shaft, nothing. Existing bolts, loosen, install, tighten, walk away. Okay, no maintenance, no installation headaches. Here's another good example of that multi-fit bracket. We have them for a variety of standard kits, and we have more generic versions because there's 1,000 different kinds out there, but we don't make 1,000 brackets. We make brackets that are adjustable this way, and this way. So you can use an existing motor bolt, install, walk away. Very, very quick for motor shops and out in the field, very quick. Never have to pull a motor apart or pull it off of its load and then have to realign, drill, tap, all that stuff. That's all things of the past. If anyone has you drilling and tapping and doing that kind of thing out in the field, let's avoid that. Give us a call. We'd be glad to work out a solution that requires nothing other than existing motor bolts. If you do choose to use it, there's an example of a number of our multi-fit brackets for the vast variety of motors you see out there. We have a configurator online. Go to helwig.com, multi-fit brackets, type in some basic 101 information, shaft diameter, bolt distance. That's about it. It'll tell you exactly which kit to purchase. to exactly match your application. Okay. Installation recommendations, these are about the same as everything. I'm not going to go into too much detail on here. Make sure that our kit is properly installed, means to make sure that it's on the motor shaft, properly spaced. We give you the little gauge to make sure that it is. And the shaft starts clean. You have to start with a decent shaft for us and put it on, walk away. Pretty straightforward. We work with a lot of OEMs. Here are some of them. Either they mount them either internally or external to the motor case itself. We do a lot of work with OEMs because they found that our product extends the life of the bearing well beyond the warranty period, where the expense is simply shifted to the end user away from the manufacturer. But you know, if your motor fails, what do you care? You're going to eat that cost. So it gives the OEM a bad name. So they're rapidly switching over to our kit because it'll give the motor many years of service. It looks good to the OEM. It makes their premium motors acceptable for long use. So that's really all I have today. This is just a quick 101 on what we're talking about. Again, motor frequency drive, variable frequency drive drives the motor. Excellent idea. It works well. It uses something called PWM, or pulse width modulation, to make that motor turn. Very efficient. It also comes with a side effect, and that side effect is called common mode, due to the imbalances created by the pulse width modulation from the motor drive to the motor. Causes this imbalance. The imbalance couples on the motor shaft, discharges typically to the drive-in bearing or downstream connected equipment, and causes premature wear and damage to those things. We can easily mitigate that without having to pull everything apart, without having to paint silver, without having to drill and tap, without having to do a lot of stuff. Put our kit on there. If you're not sure if you need a kit, or if you think you might need one, or for any reason, this little device here takes you literally 5 seconds, and it'll tell you what the risk to the motor is, record that data, and that data is maintained for you as you test all your different motors. Or if you want to test motors over the course of you know, every 90 days for the year, you can watch for trends and things like that. So that's what this device is for. You can give Liz, you can see right there, our marketing coordinator, and there's her address. Give Liz a call with any questions you have on this webinar, or if you want additional training, if you just want to get together on a Teams meeting and talk about this thing, get a demo, whatever you like. In addition, we have local reps throughout the US. If you feel that you would like a lunch and learn or something of that nature, again, contact Liz. We can arrange this with you. Or if you need a on-site visit, me or one of our BPK team members can join you in the field and do testing. So we're always available. Our job here is to solve problems with you. Now, before I go, we did get a list of questions for this webinar before the webinar, and so we do have a list of things we'd like to just maybe quick go over with you. Here's the question list that we received. I'll just go through them real quick for you. How do we determine the quantity of grounding modules by horsepower, typical install techniques, mount versus interior versus? So every motor and application is a little different. We make brushes and kits for applications, not so much for motors. So we're more interested in your application and specifying the correct kit for you. If you have questions on these things, please give us a call. We can work through it very quickly. We have sizing charts. We have configurators. We have things online that will help you determine this. But if you're struggling going, well, I've got a 25 horsepower Baldor Super E motor, what do you think I should put on there? We can look at the motor shaft, determine which kit goes on there. We can say, well, do you have a toxic environment, a very corrosive environment? What's going on? We got a kit for you. Do we need the axial mount? Like if it's on an air handling system and we can't get radial mount, what is going on? We got a solution for you. We'd encourage you, if it's not pretty obvious from it's just some basic looking at our website, give us a call. We'll work with you on your specific application. Proper grounding. Grounding is always an issue. So this kit, this probe, when you put it up against the motor shaft, one of the first things it does, it looks at the it looks at the ground and it wonders and it takes a look and it goes, does that seem like a pretty good ground? It'll tell you if you have a bad ground. If you have a bad ground, you'll see it as a test result. It'll record that and it won't allow you to continue to test. The last thing we want is for you to be fooled or otherwise misled by the test results. Bad ground, bad test result. We won't allow it. Other testers that are out there, you simply hook an oscilloscope up and you test the motor shaft. You could easily be misled by the data if your ground is inaccurate, if the settings in your scope are inaccurate, or if your technician in the field is not very familiar with how to read these discharges. Remember, we're looking for a discharge, not a dissipation of voltage, not an error, not noise. We need to be able to look specifically at the discharge and not be misled by other influences. Do you have any questions on that? Again, that's what we're here for. Heavy duty applications are not unlike any other application. If by heavy duty you mean like a big truck out in an open pit mine or maybe in a steel mill, we do them every day. Give us a call if there's a specific contamination or very dirty environment, things like that. We make specific grades exactly for that. So again, just give us a call. Here's the next question. We are having issues with the motor gearbox fluiding in our DC drive systems. Do you have suggestions to reduce this issue? Again, the discharge, the voltage builds on a shaft, and it doesn't necessarily have to discharge through the drive and bearing. It only typically does. We see on a regular basis where gearbox or other downstream equipment is as the teeth lock up in the gearbox, they become the path of least resistance. So the discharge does not bother going through the higher resistance drive and bearing. It travels down through the connected equipment, through the teeth of the gearbox, and discharges through there. And gearbox teeth wear out. We see it. We have application data on that. That's a common thing. We can get our kits on there and we can save the gearbox or other downstream equipment the same way we would save the bearing in your motor. Not a problem. Diesel-driven engine. How can we prevent voltages getting to engines, crankshaft, and bearings? This is not something we do every day, but we have done this a number of times. I specifically have. Again, if we can find a place to put our kit, which we always can, and we can get the ground, determine which is the correct ground, because remember, there's multiple ground planes. Grounding is more complex than it seems on the surface. We can pull those voltages away, whether it's on a diesel engine driven or a gearbox or harsh duty or just a standard install. It's all the same. We're doing the same thing. It's just the method that we use might have to tweak because of the very unique situations we bump into. But typically, we're talking about putting a brush on the source, getting it to the proper ground. Harmonics. How do you do with harmonics? Harmonics are treated the same as discharges. Even we're getting way up into high frequencies. Harmonics, 6, 7 out harmonics out there, whatever. We don't care. We use silver graphite. We do not use carbon or carbon blocks like some of our competitors like to mislead you on. We don't do that. And we don't do it for a real good reason, because it won't work at high frequencies. That's why we put silver graphite in. And harmonics, we don't concern ourselves with that. Projected life. Even our smallest little kits for little motors that are tucked inside there, we're still talking minimum 5 years under 24/7 application, 24/7 forever. The things just last forever. Two things cause wear in a brush: electrical from arcing and mechanical just from physical wear. This is not a DC brush like you might think of that has to be replaced every so often. It has no electrical wear because it's, remember, we put a spring in a silver graphite brush and we maintain contact. So as soon as there's any voltage on the shaft, it's immediately dissipated. Before there's any arcing, no electrical wear. Now, the brush rides on a nice, smooth surface. It's a motor shaft. It's between, 16 and 30 and 63 RA. It's a nice clean shaft. We put down a nice conductive brush path that acts as a lubricant. That brush lasts forever. 5 years, I wouldn't even, 3, 5, 7 years, depending on the application, we can work on that. We have a calculator specifically for that because we've done a lot of testing here, so we can literally calculate what the wear rate will be for each individual brush based on your application. Many years, it's just going to be that way. Okay, is it possible to identify if the charge source is from electrostatic or electromagnetic in turbo machinery, compressors and other things? So we don't care where the source comes from. We take the voltage that's from typically a motor drive, but could be coming from a number of other sources, even downstream back into the motor this way, instead of from the drive to the motor, downstream equipment injecting a voltage onto the shaft. It doesn't matter to us. Now, can we use this tool to track down the source? Yeah, we probably can. It's not what it's designed for, but it's a tool. It will measure where the voltage is, discharges specifically. And if we isolate and you call us out or one of our field reps out, we can probably track down the source of that. And again, I don't really care what the source is, as long as we can easily mitigate it. Who cares? Just get rid of it. Okay. Maximum shaft voltage or current on a motor. Again, current follows voltage. We can see there's a definite correlation between the two. We've done extensive testing in this area to make sure. What we consider a discharge of damaging effect is 2 volts. 2 volts and above is damaging your bearing and your grease. There's no question about it. Extensive testing proves that to be true. It's actually around 1.6, 1.7, right in that neighborhood, where we actually see the breakdown. We say if we're right on the edge at 1.6 volts, let's say, we upped it to 2 volts. And we say if you're seeing by 2 volts, you are seeing damage. Whoever tells you different, well, we'd like to talk to them, because I think we have all the evidence to show that that's not true. Okay, 2 volts. That's where the threshold is on this device. And we can also see that by going through the oscilloscope and through other devices to verify that. Remember, do not ever check with your voltometer. It will not give you an accurate reading. And the last question I have today is, can a Helwig distributor buy and distribute mitigation devices, our bearing protection kits? Absolutely. We have a variety of distributors in the US and throughout the world that distribute our product. If you're interested in becoming a distributor for our product, please give Kevin, you see him on the slide here, or Liz a call. They'll be glad to begin the process of setting you up as a distributor. That includes the training, how you sell it, displays on your kit, information to pass out to your customers. Liz will work with you to get something up on your social media, and we work with you as a partner if you become a distributor. So I hope that answers most of your questions, and thank you very much for joining us today. Again, if you have any questions, contact Liz, and she will be glad to set up additional training, more specific information, or a demo at your convenience. Okay? Thank you. Have a good day.